Hey everyone, and welcome back to The Explainer. Today, we're zooming in on the absolute very first part of the mobile network. In fact, it's a piece of the puzzle that is probably sitting in your pocket, or maybe resting on your desk, or even strapped to your wrist right this very second. We honestly take it for granted, but the level of engineering required to make a little slab of plastic and glass communicate at the literal speed of light is just absolutely staggering. We are talking about the user equipment, or UE. It's the ultimate gateway for all of our network data, and I am super excited to walk you through exactly how this underlying architecture really works.
Okay, let's dive into this. What exactly makes a device smart enough to talk to a cell tower? I mean, we toss that word smart around all the time, right? Smartphones, smartwatches, smart meters. But what is actually happening behind that glass screen to make an incredibly fast wireless connection even possible? Let's look right past all the slick marketing jargon and the pretty user interfaces to examine the real, raw RF engineering happening out of sight. Because it's definitely not magic. It's this highly orchestrated symphony of hardware and software, working within some really strict physical limitations. The mechanics of how your device screams into the digital void and actually gets a response back are absolutely fascinating when you finally pull back the curtain.
So, in the 3GPP standards, which are basically the global rulebooks for telecommunications, user equipment, or UE, is the formal name for literally any device a customer uses to connect to the cellular network. In telecom engineering, it's the absolute starting point. Before a single solitary packet of data is transmitted, before a handshake is completed, or before you stream even one frame of high-definition video, the entire process starts right here. The UE is the physical bridge where what you want to do, or what a sensor needs to report, gets translated into the universal language of the cellular core. To really understand the network, we've got to understand this gateway first.
All right, moving on to Section 1, Form and Scope. And as you'll see, it is not just a smartphone.
Now, what's really interesting about this slide is the sheer variety here. We traditionally picture smartphones and tablets as the main things using the network, but the mobile network itself, it honestly doesn't care if it's an iPhone or a smart water meter. Today, massive IoT trackers strapped to shipping containers out in the Pacific, automated factory meters, and those 5G home routers actually make up a huge, rapidly growing chunk of all global network traffic. Here's a surprising fact for you. Industry projections show that automated IoT devices actually vastly outnumber human-operated devices on these cellular networks. So the golden rule is really simple. If a device has a cellular baseband chip inside and talks to a cell tower, it's technically a UE. It's a much bigger, much more automated world than just the screen you're holding.
Next up is Section 2. We're going to crack it open and look at components, hardware, and SIM essentials.
Every single piece of user equipment relies on this incredibly tight marriage between physical hardware and secure identity. On one hand, you have the RF transceiver and baseband processor doing all the heavy lifting. These are microscopic internal antennas and highly specialized chips that do the intense math required to turn your digital data into physical radio waves and blast them out into the air. On the other hand, you have the SIM, which acts like a secure vault. Now that could be a little plastic card or an embedded eSIM soldered right onto the motherboard. The SIM holds your subscription profile, proves your cryptographic identity to the core network, and essentially grants you safe, encrypted access. And these two parts, they are entirely codependent. Fun industry fact, when field engineers are trying to fix a completely dead connection, they almost never look for a complex network fault first. 9 times out of 10, a scratched SIM card, a burnt-out RF chip, or a loose antenna is the real culprit for a device not connecting.
Which brings us to Section 3, Function, and specifically the 3 invisible background jobs.
So what is the UE actually doing when it's just sitting there quietly in your pocket? Well, it's definitely not sleeping. It performs 3 major non-stop jobs to keep you ready to go. Step 1 is signal scanning. Even in an idle state, your device is aggressively listening to the surrounding airwaves, scanning signals to lock onto the strongest, best quality cell tower nearby. The second it needs to connect, we hit Step 2, authentication. It securely fires off cryptographic keys from your SIM card to the core network to officially verify who you are and establish an active session. Then comes Step 3, which is incredibly cool, handover. Imagine you're driving down the highway at 70 miles an hour, streaming a podcast. As you zoom away from one cell tower and its signal starts dropping, your UE is constantly sending measurement reports to the network. Together, they negotiate a handover to the next approaching tower with millisecond precision. Your data gets rerouted so perfectly that your stream doesn't buffer for even a fraction of a second. It's this beautiful, invisible dance happening all the time.
Okay, let's jump to Section 4, Transmission.
This is what we call the two-way street.
And this brilliantly illustrates exactly how this two-way street operates. Understanding the asymmetry here is absolutely crucial to understanding mobile performance. During uplink, your device is actively transmitting radio power up to the tower. And historically, this is the main bottleneck. Think about it. Your UE has this tiny little battery and a microscopic antenna tucked behind a glass screen, but it has to scream loud enough to reach a tower that might literally be a mile away. Now, downlink, which is receiving signals down from the tower, is a totally different story. That base station has access to massive power grids and enormous high-gain antennas, so it can easily blast heavy data over a huge area. This is exactly why your download speeds are almost always way faster than your upload speeds. Ultimately, the UE's hardest job is balancing these two highly unequal directional paths, managing its own battery life millisecond by millisecond to keep you perfectly connected without killing your battery before lunchtime.
So as we wrap up today's explainer, I want to leave you with a quick thought. Next time your device seamlessly connects to a new tower while you're streaming a video on the highway, take just a second to appreciate that invisible handshake happening right there in your pocket. We've uncovered a lot of unseen complexity today, from the heavy mathematical lifting of the baseband chips and the secure identity locked inside your SIM to those constant, silent negotiations your device is making with towers miles away. It really is an absolute miracle of RF engineering, secure authentication, and millisecond perfect timing, and it is all just hiding out in plain sight. Keep looking for the invisible tech that makes your day-to-day life possible, and definitely never stop learning. Thanks so much for joining me today.